Hello and a very good day to everyone. We are from Team 3 from Mass Balance Section 3. Our team members are me, Ko Yong Hao, Joanne Liu Xin Hui, Yu Chi Ho, and Taiwan Lin. Today we will be discussing the solution for question 9. The question states that 10,000 pounds per hour of a 30% by weight solution of sodium carbonate is combined with a recycled stream and is fed to an evaporator. The concentrated stream leaving the evaporator is fed into a crystallizer in which it is cooled, causing crystals of solid sodium carbonate to come out of solution and then filtered using a filter. The outlet streams of filtration process from a filter are wet filter cake and filtrate streams. The wet filter cake contains 3.5 pounds of crystal of sodium carbonate per pound of solution, and the solution in the filter cake and recycled filtrate solution both contains 17.7 pounds of sodium carbonate per 100 pounds of the solution. Question A asks us to redraw and label the process flow diagram given in the figure completely. Question B asks us to calculate the mass flow rate of crystals in pound mass per hour produced from the filter. C wants us to determine the mass flow rate of water in pound mass per hour evaporated from the evaporator. And D, if 40% of the water fed to the evaporator is evaporated, what is the ratio of recycled filtrate solution to the fast stream? And E, is it possible to replace the evaporator with the dryer? Give your reasons. And F, one of the project engineers from a sodium carbonate crystal company suggested that the recycling stream should be removed from the existing process for a new proposed plant. Why did the project engineer suggest the idea, and do you agree? In this question, Unit 1 is the evaporator, Unit 2 is the crystallizer, and Unit 3 is the filter. And as for the abbreviations used, sodium carbonate is labeled as N, water as W, crystal as C, and solution as S. And this is the redrawn process flow diagram of the question 9, where we have the feed stream F combined with stream S6 into S1 fed into the evaporator, where it separates the water in S2 and the concentrated solution in S3, which then fed into the crystallizer, which crystallizes the crystals out from the solution as S4 and fed to the filter, where the filter separates the filtrate as MR in S6 and the filter cake as S5.
For question B, it asks us to calculate the mass flow rate of crystal produced from the filter in the unit of pound mass per hour. And we choose boundary A because by doing the DOF analysis, we found that there's contained 3 unknown variables, which is M2, M6, and M7, and 2 material balance, which is water and sodium carbonate. The symbol S should be N, so there's a little typo here, and 1 process spec, which is the ratio of crystal to solution in stream 5, and it is equal to 0, which means we can use boundary A to solve this equation, to solve this question easily. So at first, we solve for the process spec first. We found that M6 over M7 equal to 3.5 pound mass over 1 pound mass. And rearrange this equation, we label it as equation 1. And next is, we take a look at water balance, which is 10,000 times 0.7 equal to M2 plus M7 times 0.823. At this stage, we didn't consider M6 as in water balance. It's because M6 is crystal, which only contain pure crystal of sodium carbonate, so which do not contain water, so we didn't consider it in the water balance equation, and we label it as equation 2. And the total balance in equal to out is 10,000 equal to M2 times M6 plus M6 plus M7, and we label it as equation 3. So now we substitute the equation 1 and equation 2 into the equation 3, and we can get the final answer, which is the mass flow rate of crystal produced from the filter is 2,855.6 pound mass per hour. For question C, determine the mass flow rate of water evaporate from evaporator in a unit of pound mass per hour. At here, we also choose boundary A because by doing the DOF analysis, we found that it contained 2 unknown variables, which is M2 and M7, and 2 material balance, which is water and sodium carbonate. And it also equal to 0, which means we can use this boundary A to solve the problem. So from equation 2, we derive from the question B just now, which is M2 plus 0.823 M7 equal to 7,000. And we substitute the equation 1, which is this one, M7 equal to 0.2857 into this equation 2. We get the mass flow rate of water is equal to 6,328.5 pound mass per hour.
Next, I will continue with the next questions. If 40% of water fed to evaporator is evaporated, what is the ratio of recycled filtrate solution MR to fresh rate? Okay, in these questions, we use two boundaries, which is boundary B and boundary G. So the unit 1 stands for the evaporated system. Okay, for the unknowns, there are 4 unknowns here, which is M1, M3, X1, and X2. 2 material balance, sodium nitrate, and water, and 1 process spec given by the questions, which is 40% of water from fat evaporated. So there are 1 underspecified, but it can be solved partially. From the process spec, M1 times 1 minus X1 times 0.4 percentage equal to 6,328.5. This is our equation 1. Then we use boundary G, which the bed mix with the recycle stream and get the mixtures. Okay, so there are 3 unknown, M1, MR, and X1, and 2 material balance, sodium nitrate, and water. There are no process spec given in this boundary. So there are 1 underspecified, but it can be solved partially. So we use the water balance in equal to out, 10,000 times 0.7 we get the water, and MR times 0.823 we get the water from the recycle streams equal to M1 times 1 minus X1. This is our second equation. Then we sub our first equations into the second equations. We get our MR, the recycled filtrate solutions, is equal to 10,718.4 pound mass per hour. So after we get the MR and we have the fresh fed, the value of fresh fed, then we can get the ratios, which is 1.0718. I'll pass to the next. Thank you.
Alright, so for this problem, I will be present about, is it possible to replace the evaporator with the dryer? So the reason is no, because an evaporator's function is to concentrate a solution, whereas a dryer functions is to dry out a wet solid. So since the input is a solution, a dryer which requires a wet solid feed cannot be operated properly.
For question F, it gives us a scenario where one of the project engineers from a sodium carbonate crystal company suggested that the recycling stream should be removed from the existing process for a new proposed plant. Why did the project engineer suggest that idea? Do you agree? We agree with his idea because the mass fraction of water in the recycling stream is 0.823 pounds of water per pound, whereas the mass fraction of water in stream F is 0.7 pounds of water per pound. Since the mass fraction of water in the recycling stream is higher than that of in stream F, thus the recycling stream carries a more dilute solution of sodium carbonate as compared to the feed solution, and thus mixing the two streams together dilutes the feed stream and increases the amount of water needed to be removed by the evaporator to obtain the same concentration of sodium carbonate solution. Hence, the project engineer suggested the idea to increase production of sodium carbonate crystals by increasing the concentration of sodium carbonate solution fed to the crystallization process. That's all from us. Thank you.